We have scheduled two sessions today. The first session is from 7 o'clock to 8 o'clock, and this session will be taken by Dr. Karan Singh. And the second session is from 8 o'clock to 9 o'clock, and that session will be taken by Dr. Lalit Singh, sir. So Dr. Karan Singh is a professor in Jawaharlal Nehru University in New Delhi. He has received his PhD from MNIT Allahabad. His core research interest area is computer network security, multicast communication, and software-defined radio. He has published more than 100 plus papers in SCI and SCI Scopus and conferences. Sir is also an editorial member of Journal of Communication and Network USA. He has associated with number of professional societies like ACM, CSTAI, EEE, etc. He has also nominated for the award Who's Inward in 2008, sir. So now I would like to request Dr. Karan Singh, sir, to address this session. We welcome Karan Singh, sir.
Thank you, organizing team, Yatri, and other fellow faculty members, dear participant. I think it is difficult to be again in online mode. I think you are from a different institute and working there. Okay. Although I will try to just provide a basic about some kind of the security and how it is going to use for calculating the trust in WSN. Okay. Just 1 minute. I am just sharing my PPT. Is it visible?
Yes, sir.
Now it is
Keep in slide mode, sir.
It is full screen or not?
Not full screen, sir. Keep it in slide mode.
Okay, just 1 minute.
Shivaji sir, recording has been started probably, na?
Yes, ma'am.
Okay.
Yes, ma'am. Started, ma'am.
Okay. मोनिका मैम, जब तक सब लोग अभी शेयर कर रहे हैं, सर ने शेयर ही कर लिया है, फोटो सेशन हो जाता है तब तक, ठीक है।
You take, no issue. Then we will start. You can take photo.
So all are requested to please switch on the camera, switch on the video. Come for the photo session, sir, with the respected Dr. Karan Singh, sir. All are requested to please switch on the camera.
Ma'am, just wait. HOD sir is also joining.
Okay.
He has joined, ma'am.
Okay, sir.
The rest all please switch on the camera. HOD sir. Monica ma'am, you please, sir has joined. Good evening, sir.
Good evening, sir.
Good evening, Anul, sir.
Good evening, sir.
Good evening, sir.
Ma'am, you please take.
Sir, you can start now.
Okay, take it?
Yes, ma'am.
Okay, thank you. So start your session, please.
So it is visible now?
Yes,
Yes,
sir.
sir.
Yes.
Visible, sir.
Visible, sir. You can start.
Now it is, I think, in full screen mode.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so today we will discuss about trust and how it is going to calculate it in wireless sensor network, and what are the different way, and we will discuss also some security aspect in a network and how it is applied in IoT and WSN. Okay, so first thing, we will start from three questions: why we require the security in any environment. So this is the first question, because there are the three things available inside of the environment. One is the threat. Okay. If you say threat means, suppose you receive any kind of the warning inside of your system, it may be disturb your operation, function, integrity, or availability of the system. Okay, so threat is just kind of the warning that can be disturb these functions. Now, another thing is the vulnerability. Vulnerability means weakness in design, configuration, implementation, management of the system. It means suppose there is a vulnerability inside of your system or environment, anyone can come, or it may be some provide the kind of the attack. It means it is a way where from where attack may become. So that may become during designing, that may become during configuration when you are configuring your system, or during implementation when your system is going to implement it, or when you are going to use it. So these are the different platform. These are the places where the weakness may become inside of the system. Now, third thing is the attack. So generally, we heard about the attack. If attack is exists inside of the environment, then we required a kind of the security. So what is exactly meaning of the security? Security means it is a kind of the protection to anything. Okay, it may be your system, it may be your laptop, desktop, mobile, or whatever you are going to use to access the services. So attack means it is a kind of the technique that provide the exploitation to and service of the system, such as the denial of service or virus. It may be active one or it may be passive one. Okay, passive means generally attacker try to monitor the environment. Second, active one, it means the things are going to achieve which is targeted by attacker. For example, the our target is attacker target is to modify the file. So that target is going to achieve inside of the active attack. But in case of the passive one, generally attacker try to monitor how to modify what are the different activity is done by particular system or particular environment. Now you just see what are the different the things is going to use to just provide the security into different kind of the platform. For example, it is a information security, it is a network security, it is a computer device data application security or cyber security. So generally we use the 3D mechanism. 3D mechanism means we generally use the difference, we generally use the detect and defense. So what is the difference between these three terms? So difference means it is a kind of the prevention. Prevention means suppose any virus is there. Okay, so suppose it will not come in our system, or it will come before suppose we will take the a new system also. So generally we install some kind of the remedy, for example antivirus. So when you purchase a new laptop also, you just take a antivirus, or already some company like operating system is there, so there is some inbuilt software that provide the facility for antivirus. So that phase is called difference. It means it is a kind of the prevention. Okay, Second phase is the detect. Detect means you need to scan regularly your system. For example, suppose there is a any virus is there. So for that you need to scan the system after 10 days, 20 days, 15 days, depend upon the how much environment is attacking. It means suppose there is a less chance of the attack, then you can take the more time. It is a, suppose there is a very high chance of the attack, you are using attacky environment, you are accessing such type of the website, or you are using work on where there is a possibility of the attack. Suppose you are using different type of the out sourcing, or like a pen drive or hard disk which may be attached to your system. So there is a more chance of the attack, then you need to scan your system regularly. Then last phase is the defense. Defense means suppose attack is there, then it may be need to delete, or it may be just quarantine it. So these are the three phase you need to apply in form of the logical one or in form of physical one. Logical means suppose you are using antivirus, it is a example of the kind of the software, or you just say we will provide the remedy in form of the software. But in case of the physical, you just provide the remedy in form of the hardware. For example, suppose there is a some antivirus on your system, but sometime if suppose anyone steal that system itself, then what happens? Then you need some physical solutions. For example, CCTV is there, security guard is there. Okay, so that will be a form of the physical one. Now we try to understand what is the model, what is the security model, what are the different component in security model. So already, if you read the books related to security, there are the three or four terms you just listen about: the Alice, Bob, Trudy. Okay, so the network model is defined based on these three kind of the characters: Alice, Bob, Trudy. These characters generally used in protocol of the RSA. First time, it is taken from one drama. Okay, same way, if you want to understand, you can use the different character also. Okay. For example, these are the two friends. Already you know these J, Viru, these are the friend and want to communicate to securely. But there is a one intruder or opponent or attacker inside of the channel. So there is a some data which is going to generated by source, and there is a other side destination, which is the recipient of the message. So objective in this network is that the message should be reached to destination in secure manner. It should be there should be no modification is possible during when it is going to transmit it or inside of the channel. But attacker try to access or try to modify, it may be delete or relay. Okay, with that message, it may be there is just some technique with the attacker. Okay, now we try to understand what is the behavior and what is the type of the different attack. So one attack is called
Tejas?
eavesdropping. So what is eavesdropping? It is a just kind of the attack on confidentiality. So if you try to understand what is confidentiality, it may be suppose someone want to unauthorized access of the information. It means confidentiality will be breached. Second, if packet is going to just sniffer or wiretrappers, as if suppose someone is sending the illicit copy of the file and program, you can understand with these behavior of the attack that attack may be possible on confidentiality. So you just note down this is the one type of the attack which is happen with confidentiality if such activity is going to happen. Now another type of the attack which may be possible on integrity. Okay, so what is happening in integrity? There is a tampering with message. So what are the activity of this attack? Just attacker try to stop the flow of the message. Okay, it may be delay or optionally modify the message or release the message again and again. Suppose there are the two friends, and if someone is sending trying to stop the flow, or trying to delay the message, or release the message again and again. Then we say it attack on integrity. Okay, so this is the second type of the behavior, or second type of the attack. You just try to understand the behavior that is the base on these three activity. Now another attack is called attack on authenticity. Okay, that is called in general fabrication. So in this case, unauthorized assumption of the other identity, generate and distribute the objects under this identity. It means someone just try to use the identity of other one and try to access the services of system or environment. Now this is the attack on availability. Attack on availability means, suppose someone destroy the hardware, or cutting the fiber, or try to stop or just corrupt the software, modify the software, or corrupt the packet into just transmission. Okay, it means the service which is provided by some node or some system, it is unavailable. So generally in this category, DOS is very famous attack. Due to DES, some server are going to crash, or it may be slow sometime. So if a DOS attack is performed on particular system or server, laptop, desktop, so performance will be down, or the service will be unavailable for usage. Now, if you identify the type of behavior, if you just try to understand what is the behavior of the attacker, and which type of the attack is performed inside of the laptop or desktop or environment, it may be or wired, or it may be wireless. Then according to just behavior of the attack, you just provide the remedy. For example, suppose attack is happen on confidentiality. It means you just provide the encryption and decryption process to provide the security. Suppose attack is happen on data integrity. It means you just provide the MD5, SHA. It means hash algorithm is going to use. Generally, antivirus is the one example that use the integrity service. If suppose attack is related to availability, then you just provide the redundancy kind of thing, or you just provide the some IDS, IPS kind of things solution. If attack is happen on authentication, then you just use the digital signature, digital certificate, or some PKI kind of thing. So according to the type or kind of the behavior, you just use the remedy or provide the security. So if you just recall that these things, we have only attack. So you just remember one thing, that is attack. If attack is inside of the environment, it means there is some need of the security. If there is no attack inside of the environment, then no need of the security. Simple. But generally, there is some chance of the attack inside of the environment. It may be passive or active. Then we need to detect with help of the mechanism that is called 3D. Okay. So how we just detecting the attack with the help of the 3D mechanism. Then inside of the 3D mechanism, generally we use the command. So command is a just kind of the security goal or security services. It is having like 5 pillars. In some book, it is a CIA, confidentiality, availability or authentication, and integrity, CIA. Then it may be just kind of the extension of the CIA, confidentiality, availability, message integrity, authorization, non-repudiation. Okay, so these are the 5 pillars. So here is one question generally I will ask to participant. Will we use the all kind of the solution at a time for a system? What is your response? It is yes or no? Anyone? Hello.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Suppose we have the 5 solutions, 5 security services. Can we use all at a time? Answer is yes.
No, sir.
So who is there saying no? Yeah.
No, sir. Ganesh.
So answer is yeah, no, because you just see this very simple. I mean, just example. Suppose there is a one person, it may be me and you, and suffering some of suppose one day disease like fever. Then what is the next step? He or she will meet to doctor. Then doctor will write the medicine. So you just compare the entire kind of thing with this what we have discussed. What is the attack here? It is a disease. Okay, and there is some network administrator like it is like a doctor. And what is the medicine here? Medicine is the command. Okay, so in medicine, if you visit the medical store, how many tablet is there? How many type of the medicine is there? You can just imagine. So same way, there is a different type of the protocol, different type of the algorithm is there in one kind of the letter like C confidentiality. It means in confidentiality there are the multiple solution, different type of the solution is there, different tablet is there like medicine. So it may be 10 mg medicine is there, 100 mg is there, and different kind of the for disease there are the different medicine is there. So your doctor will write the medicine according to type of the disease. Simple. So suppose disease is related to confidentiality, so doctor will write the tablet related to confidentiality. Already, if you see, we have discussed here. So already we have the different type of the disease. It means we will provide the solution or medicine according to that disease. Clear? So at a time, suppose some answer was the yes. Suppose you will provide the all medicine at a time. You just see here. Suppose there is a suppose 100 tablet, and there is a many type of the tablet in medical store. But suppose you have the 100 tablet in medical store, and your doctor will write all 100 tablet at a time. What happen? Can you imagine? Okay, you will be okay. So same thing will be happen with your system if you use the all kind of the service at a time. So your system may be slow down or crash. Okay, why? Because there is a two thing. One objective is to provide the security. Obviously, in this case, suppose you are using command, your system will be very secure. Okay, but the overhead of that security will be very high. Due to that overhead, the system will be slowed down. Clear? So we will not use the all services at a time. Okay, in general, but specific for specific case we can use. If suppose we have the you just say the very high perform suppose we have HPC kind of the system, high performance computing power system, or it is a requirement of the environment. Sometimes we take the Z++ security. So that time we need to apply all. But in general case, we will not use them. Clear? Now this is the division how we can apply the kind of the solution. Suppose you are providing the solution inside of the environment. For example, some person are related to, they are developing some kind of the application, so they will use here the solution inside of the application protocols. Okay, suppose someone is going to use the provide the some kind of the software or solution for quality of service, for Wi-Fi, for cellular, then the security is going to provide in this part. Suppose the some group is working in a kind of the developing phase, like in infrastructure level. For example, they are working on router, switch, server, or Ethernet links. Then we need to provide the security here. So this is the division in form of the just dividing the entire environment. For example, there is a one environment, and we are going to divide into kind of the vertical. So first layer is called infrastructure, second layer is called service, and last layer is called application one. If we are going to provide the any solution, then we will select any one kind of the layer. Okay, this is the our targeted layer, and we will provide the solution here. So it is depend upon your kind of the area or interest. Now, suppose we again divide this environment into horizontal way, then we say it the plane. Okay, so one division is called your vertical one, and one division is called your horizontal one. So that is called complete planes. So plane one is called end user plane, plane two is called controlling and signaling plane, and last one is your management security plane. So in each and every plane there is a all three division of layers. Suppose you divide the environment in this way, vertical one. So what is the inside of the end-to-end? Suppose you are using any kind of the security or any kind of the services which is used end-to-end one. Then it will cover here. Okay, we will provide the security at end-to-end level, source to destination one. But suppose sometime you are using or you are sending the data, then it may be used the controlling or signaling kind of thing. Then we will use the controlling or signaling security plane. But sometime we are managing the kind of the some security things. Then we will use the managing security plane, last one. So what is the just kind of the different protocol exists inside of these different plans? So like HTTP, RTP, POP, TCP, UDP, FTP, IPsec, these protocol exist inside of the end-to-end one. But inside of the controlling and signaling plane, there is a BGP, OSPF, or kind of the routing protocols. And other side there is a managing kind of the protocol like http, ftp, telnet, and snmp. So you just see here the http also exists inside of the management, and http also exists in end to end. So what is the just kind of the difference here? Suppose you are going to use any kind of the protocol on your system, then it will be your end user. But suppose that protocol is used for configuration purpose, so that on your server side it may be just kind provide the configuration or security remedy on http. So if we are talking about the server side, it will come into management. If suppose you are going to use it on your browser, then it will become inside of the end user side. So that is the difference between if you are using the http here, if you are using http here. Now if we talk about the just kind of the one slide about the network, what are the different type of the you just say the part or component is there. So type, if we talk about it, is the LAN, HAN, CAN, MAN, WAN is there. If we talk about the media, generally there are the two type of the media is going to use. Already you know, wired and wireless. If we say the topology, topology means it is a physical kind of the just say the connection between different type of the nodes. Suppose there is a some system. If you want to connect those, it may be form of the tree, mesh, ring, bus. So there is a pros and cons. Accordingly, we use any one or two combination of the topology. The main part of this communication or network is the protocols. So those protocol come from the layers, and these layer is depend upon the models. So there are the two type of the model. One is the OSI model, and second one is the TCP/IP model. So these are the layers which is divided into different parts. If we talk about the TCP/IP, this is the physical one, data link layer, network layer, transport layer, session layer, presenter. These are covered into application layer. So if we talk about the sets of rule, the meaning is that is the protocol. So there are the different protocol exists on different layer. For example, on application layer, already we have talked about the HTTP is there. On transport, there is a UDP, TCP is there, and on network there is a IP is the main protocol, and these are the some supporting protocols. Now, Same way, suppose we divide or just try to understand in one slide what are the meaning of the network security or kind of the security. So already suppose we are going to provide the security, then we can provide the security depend upon the media. So we can use the wireless or wired. Suppose we are using the connection, it may be wired or wireless when we are going to provide the security. If we talk about the type, there are the two type of the securities there. One is the link to link and one is the end to end. Link to link means suppose there is a suppose 100 node, then we will provide the security to 101. Okay. If we are talking about the end to end, it means you will care about the source or you will care about the destination. Okay. In other parts, suppose we say the component of the security, it is a kind of the suppose we will model or we will provide the method. Then we first provide the information about the attack, which type of the attack is there. Okay. Then we will use the one security goal or services. Then according to that we use the algorithm. If we talk about the algorithm, it will use any kind of the key with that algorithm. So key also one important component if we are using any kind of the solution, security solution. Okay. Same way, if there is some different layers in TCP/IP model, already you heard about that. There is some solution related to security on each and every layer, like Carboj, SSL, IPsec. Okay, these are the part on each and every layers. Now, this is the way how we can develop a kind of the standards or some kind of the big solution related to security. So first step is to learn about the basic solutions or basic kind of the basic terminology or technology like confidentiality, authorization, integrity, authentication, non-reputation. So you just learn about if you are the new in this area. Then if you are the familiar or already understand these things, then you just try to create a one kind of the component like AHESP. It may be just kind of the enhancement of the according to this basic one. Then these component may be used into particular one kind of the solution like IPsec having the two component. One is the AH and ESP is the another component. But inside of the ESP there is a one protocol, one algorithm that is called DES, data encryption standard, which is the basic kind of the confidentiality algorithm. So you can start from basic one, then you can generate the component, then you just provide a kind of the standard or patch that may be used for particular architecture or system one. So this is the just kind of the just terminology. What is exactly if we are using the solution based on the cryptography? So cryptography means it is a kind of the hidden or secret kind of things. So in this there is a plain text is the one thing terminology going to use that is called that is used by source. Source will use the plain text, and there is some algorithm means there is some key is going to use with that algorithm. Then you will achieve the ciphertext with the help of the encryption. Okay, encryption is the one process that provide the just kind of the ciphertext with the help of the algorithm and plain text. So that job is done by destination and the message source having the original message that is called plain text. And if we say the reverse, the destination just receive the ciphertext, again apply the same algorithm with same key, then just retrieve the original message or plain text that is called the decryption process. So these are the way. So these are the some technique which is going to use inside of the cryptography. I'm not going to discuss, but you just try to understand there is a two category. One is the symmetric and one is the asymmetric. Symmetric is generally based on single key, one key is going to use, and there are the two approach. One is the classical one and one is the block one. Block, the example of the classical is the substitution and transposition, and these are the different algorithm. But the example of the block is the DES, AES, like these algorithm. And there is another kind of the approach is the asymmetric, where pair of the key is going to use. The example of this category is the RSA algorithm. So DES, AES, 3DS is the part of the block one which is come inside of the symmetric one. Now, if we see the different category, one is the classical one, and the second one is the modern one. So inside of the modern, you just divide into two parts: secret part and secret one, and the public one. In case of the secret, you can just divide into symmetric one. Already we have discussed the block, or there is another category stream one, like RC for generally for mobile communication or to provide the security to your SIM or mobile communication. We generally use the RC5 algorithm. Okay, so it generally use the variable kind of the key. Okay, it may be 2 bit or it may be 4 bit, depend upon the situation. These are the very some heavy kind of the algorithm. Then outside there is a RSA, DSA, DPLMN kind of the algorithm. Now, and these are the some real kind of the technique which is going to use the exploit the environment. For example, SQL injection means your database is going to overflow due to some kind of the attack. Then suppose you are using some PDF files, there may be some script or some malicious code is going to insert. If suppose there is some data, some services going to availing, then DUS condition is going to apply. It means a denial of service attack is applied. Then there is another kind of the technique, that is the brute force. Suppose you are using any kind of the key, then attacker try to just achieve that key with the help of the many iteration. So or it may be use some dictionary attack. Sometimes you just use the password which is used. It may be combination of the name of the someone. Okay, it may be relative one, and sometimes you just use the combination of the 1 2 3 or something. So attacker try to brute force on that. Then sometime integer or flow. Suppose you are software is using some programming language, some kind of the integer or flow kind of the vulnerability may be there. Okay, then suppose there is just some kind of the programming code is there you're going to use, there are the some mode is there. So it may be defected. So these are the different kind of the exploitation technique going to use. These are the very few one. Now, again, we just divide the that entire environment, entire communication system, entire just say the environment. It may be your simple single mobile, it may be your single laptop, it may be single desktop, or it may be combination of. So entire system will be divided into three parts if we are going to provide the solution. So one part is there, suppose we say the cyber one. It means we are generally using some kind of the, you just say the prevention kind of thing. Prevention means you are just installing antivirus, anti-malware, firewall, anti-spam. It means there is no attack, okay? But you are just taking the remedy one. Another side is the running kind of thing. Suppose you are availing the service, it means you are just using the some kind of the cryptographic solution. It may be based on the confidentiality, authentication, integrity. Okay, or there may be some part of the sharing of the key. Okay, but last one is the suppose attack is there or it is happened, then the computer forensic is the one kind of the research, or you just say the trust area. Then you can identify the attack, who is the attacker, try to find out the just footprint, and with help of the logs, it may be happen after post attack. In this case, data is going to collect it, examine, and provide the report. Okay, this is the attacker, this is the IP address, this is the particular location where the activity is going to perform, and this is the behavior. So everything is going to catch by the technique which is used inside of the computer forensic. So you can divide the pre, you just say the in running mode, and after if attack is happened. Now If suppose you are working in the particular area, or you just see there are the some general key area, you just say the cloud is one, then cyber is one, why WSN is one, IOT is one. Okay, if you are working in communication, generally you are going to use a wireless sensor network, or you are using Internet of Things. Okay, in case of suppose you want to store your data, it may be you are using some server or you are using some cloud. Sometime if you are using any kind of the service, it may be part of your cyber one. So there is some general issue when you are going to accessing the data. So security issue may be there. If suppose you are routing the data, it means you are sending the data, then there is some possibility of the attack. Then the issue may become during the routing. Suppose you are connecting the device, then or some device are going to switch from one place to another place, then switching at the time of the switching there is some possibility of the security. So in general you require the security for data, or you require the security for web or API, or you require the security for communication or for channel. And you can use this command, already we have discussed. We can use C or A or M or A or N at a time, or combination of the two, not all. Okay, so if we talk about the IoT security, then there is a possibility of in case of the IoT, there is just some solution. For example, because IoT is the lightweight kind of the device. So in IoT, generally we use the lightweight solution. So there is a one solution like attribute key encryption, attribute based encryption technique. So in this case, generally we use some attribute to provide the encryption. Like suppose your original message is going to convert it into another form. Suppose any device want to send the some message to another kind of the server or any other device. So it should be in encrypted form. In this case, generally we use some attribute. So if those attribute is there in other side, it means that data is just decrypted or authentic one. If those attribute is not there, it means it is not authentic or it is not a secure one. For example, suppose the attribute doctor and this director is going to use when the encryption process is going on, then another side it is going to verify if director and doctor is in the entire message, then it means the attribute, based on the attribute, the data is authentic one. In this case, doctor is there and one another category is the surgeon one. So the both kind of thing is not available, which are the used inside of the source. But another part it is going to verify, so this message is okay and this is not accepted one. Same way there is a another technique that is called cyber policy attribute based encryption. So in this case, access policy also going to use. Access policy means sometimes we provide some logic and or okay. So based on that logic, suppose there are the three kind of the attribute is going to use. So if we are using or here, it means this one or any one. If these are the available other side, it may be okay. So here the attribute director is available because it is inside of the logic with or, so it is okay. And here because there is a some surgeon and doctor is not the kind of the attribute is there, so it is not accepted. So inside of the IoT security, the privacy is the one challenging issue. So there are the three kind of the challenges there. One is the anonymity, and another one is the unlinkability, and third one is the untraceability. So in this case, suppose first one, anonymity, the property ensuring that third party is the unable to identify the person identity among other identity in system. So that is called the anonymity. And in case of the unlinkability, there is a impossibility to cover the person's identity from information they produce. Okay. And last one, it is difficult to track the action and information used issued from a behavior of an entity in system. So inside of the because in environment, suppose you are using many IoT device. Okay. So these properties going to apply because the privacy, suppose we know which type of the device is there, what is the name of the device or IoT device, then it is easy to attack on that IoT device. Already it is the low kind of the memories there, very small memories there, so there is a more chance of the attack. It may be suppose the service is unavailable, or it will be stop the transmitting the data from particular device to servers one. So these property need to verify if we are using the any kind of the solution or providing any kind of the product related to IoT one. Now we will discuss the another part that is called the trust one. So already I think previous speaker told about the WSN, what is exactly WSN, and in future also suppose upcoming speaker will tell about the what is exactly WSN and what are the different application of the WSN. I am not going to discuss about that. So there is a different component related to WSN and how it is going to use. There is a one kind of the unit, and there is a some nodes. So those nodes send the data from one node to another node. It means suppose this is the one node which is going to sensing something, then it will forward the data to another one. It may be there is a chance, or there is a some you just say the mechanism to save the energy. Okay. Then finally one node which is the last one, it will send the data to sync one. Then via sync, it is send the data to directly your last end user, or via satellite or network. So in this your WSN architecture, data is going to just forward from one node to another, and then base station, and it will be used by end user. So already you know what is the demand of the wireless sensor network or sensor kind of the application. It will be increased day by day. There is no doubt. And these are the different kind of the application. Already you know about sensors are going to use in home application, cattle monitoring, and environment application, military application, okay, medical application, area monitoring applications. So I'm not going to discuss. There are the some issues in WSN. Already you know one issue is the limited memory and storage. Second is the limited power, and third is the unreliable communication. Fourth is the self management, and last one is the security and privacy. So we will discuss about the security and privacy. Already you know the sensor node are the very small kind of the size, and we can't charge that. So there is some limited power. Okay. And because it is just deploy into open areas, so there is some kind of the unreliability issue, and there is also there is no controller kind of thing. So there is a you some issue of the self management also. Now, generally, what are the major kind of the issue or related to security kind of the problem is there? So sensor nodes are the less reliable and failure prone, susceptible to several security attacks like on-off attacks, cyber attack, etc. And there is some kind of the activity or behavior maybe happen like misbehavior or breakdown the services. If we provide the solution, one is the technique that may be cryptographic. And if we say about the cryptographic, already we talk some, there is just some overhead related to, if suppose we apply any kind of the cryptographic solution, there is just some kind of the overhead. So already if we talk about the memory or some processing unit, so there is some limitation. So if we apply the any kind of the cryptographic solution, so we need to think about the solution should be lightweight. Okay, otherwise the performance of your night kind of the nodes or wireless network will be slow down. So what is the purpose of that WSN? It will be a huge one. So already there is a different type of the layer in WSN. According to those layer, there is a different kind of the attack is there. Okay, for example, on physical layer, there is a tampering or west dropping or jamming is possible. Then solution is there, hash based already, MD5, SHA. These are the hash algorithm, and other cryptographic technique may be applied. Then there is some chance of you just say the data link layer. It may be there is a black hole, hello flooding, sinkhole, wormhole attack may be possible. On network, there is some misdirection, gray hole, or you just say the related to routing protocol, there is some attack is possible. Then on transport layer, there is some cyber attack, selective forward attack is may be possible. Okay, and these are the some possible just kind of the defense solutions. Now, inside of the WSN security, you can provide the solution related to cryptographic one. It may be asymmetric or symmetric. Already we have discussed what is the symmetric or what is the asymmetric one. So any one algorithm which is the lightweight, it may be applied if you are providing the solution inside of the WSN based on the cryptography. Okay. Then another the challenge is the data aggregation. When data is going to aggregate, so that time suppose there is any issue, you can just tackle with secure manner. If suppose the data is going to route from one node to another node, then and there is some chance of the attack, the flooding may be possible due to attack, then you just handle with the security solution. Suppose you are just finding any kind of the node, it may be localization one problem is there inside of the WSN. Then again, you need to provide the security with the localization. Okay. And then there is some location aware security solution is there. And the last one is the node behavior. Suppose the behavior of the node is not a good one, then you just try to identify how we can just calculate the how we can identify the behavior is okay or not. So this is also one challenge, and we can provide the solution accordingly. Now, one the big challenge is the key management in WSN, because there may be some suppose 100 node. Okay, but after some time the energy of some node will be low, it may be zero. So after some time it may be 90 node. So if suppose we assign the group key to that particular 100 node, okay, then again we need to generate the key when 10 node will be lose their energy. So in case of the heterogeneous or homogeneous, these are the two category. If all resources are you just say the same, it is a kind of the homogeneous. If there are the different kind of the memory or different kind of the processing unit, then it is the heterogeneous environment. So if there is some the thing means the key are going to change after some time, then the issue is related to key management. So these are the different issue, and you just say the gray area where you can work in WSN, just apply the any security kind of the solution. Okay, so key management is the very big challenge in WSN. So suppose node is doing some misbehavior, it means there is a different type of the solution is available. Okay, so there is a communication misbehavior or sensor data misbehavior. In this case, the suppose the data is going to forward or routing, then there is a some node is not forwarding the data or not routing the data. It will be category of the misbehaving inside of the communication one. Other side, suppose there is a faulty node or generating some noise or there is a communication failure, it will come inside of the sensor data node misbehavior. Now the solution related to suppose there is a misbehavior kind of the activities happening inside of the nodes, WSN nodes, then we just provide the solution with the help of the trust one. Okay, so trust value based scheme is there, and we just use those scheme and try to identify which node is doing misbehavior and which node is not doing the misbehavior. Okay, so today we will discuss about the trust value based scheme. What is exactly trust? You just try to understand. Trust means there is a some kind of the cooperation. Suppose there is a some node and there we provide the some kind of the job to particular node, and suppose they are not doing or they are not cooperating to each other, it means node are doing misbehavior. If there is a some kind of the reliability or trustworthiness between those node, it means it is a trustworthy. Okay, trust means reliability. If you want to remember the term trust, what is exactly, it is a kind of the reputation also, or it is a kind of the opinion also to about other one. So trust means reliability, trustworthiness, or you just measure of the assurance. Okay. So reputation, what is again reputation is there. Reputation is the opinion of the entity about another, or can be used or determine the trustworthiness of the entity. So there are the two type of the interaction is there. One is the direct interaction. You just say the first hand information calculated by just immediate neighbor of the node. It may be direct interaction is going to happen. For example, suppose there is a one node A, okay, and it is sending the packet to node B, and again node B is also sending the acknowledgement of that packet. It is called the direct. You just say the interaction, okay. And another category is there. Suppose we are going to calculating the data trust. Suppose it is sending the data. So if this interaction is happen between direct one or indirect one, so that is called the just data trust. If hello, is there,
Yes, sir.
yeah, is there any issue? Hello.
Hello.
No, sir. No, sir. No
Yes.
issue, sir. No issue.
Okay, sorry. So another category is called indirect interaction. So one kind of the interaction is the direct one, and another kind of the interaction that is called the indirect. It means the information is taken by second hand. Okay, it's the second hand information. It means suppose we want the information from node B, and so they know suppose the direct connection. So it may be depend some intermediate node, so we will send the first packet to this one and it will be forward to this one. Then reply will come here and that reply will send to first one. It means the information is coming from another node. So that kind of the interaction is called indirect one. Okay. Now another terminology is the trust level. So there are the three kind of the level is there. Level one, you just say range is greater than upper threshold. There are the two kind of the threshold is going to use when we calculate the trust. Okay. Suppose you want to calculate the trust, it means there is a some kind of the level For example, suppose there is some threshold value. It may be 0 to 100, it may be 0 to 2, it may be positive or it may be negative, whatever you want to take. But you will take one upper threshold and one lower threshold. Okay. For example, the trust value is 0 to 10 and upper threshold is 4 and the lower threshold is 4 1. Based on this threshold, you can categorize the level of the trust. It is trusted, it is untrusted, or it is uncertain. We can't decide it is. So, what is the meaning of trusted? Suppose the range is greater than, you just calculate the trust of particular node and just compare with threshold value. Is it more than that? If it is more than that, the node is the trustworthy. Okay, it is not doing any misbehavior. Suppose the range is less than upper threshold of the trust, then you just say it is a malicious node. Sometime it is between that upper and the lower one. It may be just undecided, uncertain. It may be malicious one or it may be trusty one. So these are the three level which is going to measure when you will calculate the trust. It may be trusty, it may be untrusty, or it may be uncertain. Okay. Now,
Excuse me,
already,
sir. Yes, sir. Sir, there is one issue actually, sir.
yeah.
Our another speaker has also joined, sir, and
Oh,
we have given him the time of
no issue, no
7:50
issue.
or 8 o'clock. So
So,
we have to
have
take the
any
question
questions?
answers also, sir. Yes, sir. So kindly, sir, in 5 minutes, reply to.
Okay, okay, no issue. So you just
Thank
try to
you.
understand what is exactly cooperation between a node. Already we have discussed. It may be suppose send the data and it will suppose the node A send the data to node B and it will be just reply the one kind of the acknowledgement. Okay. So node B the sending the data to node C. That is the job of the node B. Suppose it will do. It means the job is done successfully and the interaction is called successful interaction. Another is the non cooperation kind of the thing. Suppose the job of the node B is forwarding the data to node C, but it will not send that data to node C and not reply the acknowledgement. Then the you just say the interaction is called unsuccessful. Okay. So now you can calculate the trust based on you just say the cooperation or non-cooperation. For example, there is some packet is going to send by this node and some packet is going to drop. Then you just use just a kind of this mathematical kind of the formula. For example, total successful interaction between node A and node B and how much total interaction is there. So with the, for example, there is a 10 total interaction is there and 6 is the successful. Then you just calculate how many successful interaction is there and how many unsuccessful interaction is there. So you just calculate the trust value. It will be 0.6 in this manner. Okay. So these are the some property which is going to use to calculate the trust when you are going to calculating the trust behind WSN nodes. Okay, I'm not going to just escaping these property due to time shortage. So these are the classification. The one classification is the direct trust, indirect trust, energy trust, statics, and the dynamic one. Okay. So direct is suppose the interaction is direct one. It is called the direct one. If suppose the interaction is the indirect, it means it is based on the second hand one. Information is the communication is done by second hand second node, and that is called the indirect one. Already we have discussed this thing. Now there are the different kind of the attack which is going to use relate to misbehavior. It is the bad mouthing, selective forwarding, on off attack. Okay. Suppose the information suppose about the node B is provided by another one and it will reply the just reverse kind of the information, that is called the bad mouthing one. Suppose the job of this node is forwarding the data to node B, so and it is not doing same activity, so it is called the this node is the malicious node. Okay, so suppose it will be drop some packet, then it is called the malicious. Okay, on off means suppose the job of this node is to receiving the data, but it will not receive that data, so that is called the on off. Suppose we send the data and it is not available that time, so that is called the that node is doing a malicious activity this time. So suppose the researcher use the hybrid architecture. In this case, the one there is a two category. One is the intercluster and another is the intra-cluster. In this case, suppose there is a cluster head, it will calculate the trust of the entire node, and again each and every node also calculate the trust of the another node. Same way, other cluster, the cluster head will calculate, and another node will also calculate. Then in case of the intercluster, cluster head calculate the trust of the other cluster heads, and the calculate the trust between base station and cluster heads. So this already we have discussed. This is the way how we just use to calculate the trust. So first we calculate the information, then we just divide, just classify which type of the information is there. It is a successful, it is a unsuccessful interaction is there. Then we will map those information into some model, then take the decision. Okay. So already we have discussed, we will calculate the interaction, which type of the interaction is there. Okay, then we will develop the sum model. Then we decide the some threshold to categorize or to create the level of the trust, untrust, or uncertain. Okay, so information may be direct one or it may be indirect one. Then you can apply the different category. It may be weight based, probability based, fuzzy based. Then you just evaluate the model of the trust, then take the decision. Okay, these are the different category. Like there are the different analytical model is there, some bio information model is there, some socio info kind of the model is there. Okay, these are the some existing literature, and these are the some trust function is there. Suppose you develop any kind of the trust function, then you just compare the overhead and some kind of the suppose it is a better one or not. So I am not going to detail indirectly. Suppose this is the one example. Suppose you are going to calculate the cluster member to cluster member communication. So this is the one trust function which is going to develop. And this is the case. Suppose you are going to calculate the trust in indirect way, cluster head to cluster member. So this is the another trust function is there based on the this already lightweight trust estimation scheme is there. Okay. So this is the kind of the flow chart. Generally, there is just some sensor is going to deploy. Then there is just some clustering mechanism is going to apply. Then we take the decision. It may be intercluster, it may be intra-cluster, and take the decision here and decide which type of the category those node, those cluster or base station are. So this is the kind of the window where we need to calculate how much your successful interaction is there and how much unsuccessful interaction is there. So that is called the information collection based on some window. It means suppose we are going to calculate the trust value, then we need to set the some time window, and in those time window we need to calculate the successful and unsuccessful interaction. Okay. So I'm not going to doing much. So these are the some overhead kind of the communication overhead function, suppose based on the literature and proposed one. So finally, on conclusion, suppose we want to communicate to each other. So there is just some kind of the smart communication we need, but there is just some need of the communication device. It may be wireless or it may be on the WSN based on IOT. So there is a chance of the attack. Okay, so if it is a lightweight and that device or that node is going to some doing misbehavior activity, then we need to calculate the trust one. But there is some overhead of suppose you are using any kind of the function which is inbuilt or which is going to calculate the trust, and there is some function or some parameter is going to increase in a normal kind of the communication. So overhead will be increased. So we need to identify when we are going to provide the security, how much overhead is there and how much strong our solution is there. Okay. So thank you very much. If there is any query, then you may ask.
Thank you, sir. Thank you, sir, for your valuable information. There is one question from Sonu Kumar Jha.
Pagala. Hello. Hello. एक मिनट. Hello. Sir, good evening.
Good evening.
Sir, how can we manage controlling access with wireless command for data transmission?
Hello.
Yeah, sir. Am I audible, sir?
Yes, yes.
Yeah, good evening, sir. How can we manage controlling access during some data transmission with wireless command?
Hello. So you are
Monica
talking about.
Bharadwaj, please mute.
Hello.
Yes, sir. Yes, sir. Please, sir.
You are talking about the access control of access point.
Yeah, no. Suppose, sir, I want to control automatic driving car for opening door or closing door. Okay. So how do we manage their controlling access? Suppose unauthorized person also can access for opening the door. There is,
For that, suppose there is a centralized kind of the authority. For example, you are using particular kind of solution. You are saying particular ad hoc network kind of the solution is there. So
Yes, sir.
there is some, for example, there is some kind of the firewall is going to establish into service provider. It may be managed by that.
Okay, sir. Thank you, sir.
Any other question?
शिवाजी सर फुल स्क्रीन कर दीजिए.
Yes, ma'am.
And Monica Bharadwaj, please mute your mic. Monica Bharadwaj.
I have already done her mic muted. I have muted her mic.
Okay.
Thank you, Karan sir. This is a small virtual token of appreciation from our side for this wonderful session. And we are honored to offer you this certificate of honor from the Department of Electronics and Communications, sir.
Thank you, sir. Thank you, Karan sir, for considering our request and for coming here for such a wonderful lecture. Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Sir, thank you very much.
Can I leave?
Yes, sir.
Yes, sir.
Yes, sir. Thank you, sir.
Okay.
Yes.
Thank you all. Thank you, guys.
Thank you, sir. Thank you very
Thank you,
much.
sir.
Yes,
Welcome.
now Shivaji sir, please welcome another speaker. He has already joined since last 15 minutes. He is waiting actually. Sorry, sir.
Sorry, Lalit
Lalit
sir.
for delay.
Sorry, Lalit sir, for this delay. And we welcome you, sir, Lalit sir.
Thank you very
Lalit
much.
sir has received his PhD degree from Indian Institute of Technology, Banaras. And currently he is associated with NPCIL Bar, Bombay, now Mumbai. His research interest is reliability, safety, and security of critical computer-based system. He is specialized in pressurized heavy water reactors and light water reactors. He has number of publication in IEEE transaction, IEEE computer ACM, etc. And he's also a senior member of IEEE Indian Nuclear Society. He is also board of VOS members in IIT Ropar and various universities. He is also associated as an Indian professor in IIT BHU and IIT Gwalior. He has awarded with his IEEE K Shankar Award. Sir, over to you, sir. Without any delay, please.
Yeah, thank
start,
you.
sir, your session.
So thank you for the introduction. And so to start with, let me share my slides.
Yes, yes.
So are my slides audible?
Yes, sir.
Yes, sir.
Yeah.
It is visible. It is
So
visible.
I do have only half an hour now to talk because my time was 8 to 9. So
Fine, sir.
So I'll be
No problem,
talking
sir.
on reliability analysis of IoT systems. So to start with, let us go through the quick agenda. So first, I'll be introducing about the reliability. So basically, reliability is defined as a probability of failure-free operation uh, up to a given period of time and under certain environmental conditions. Now here, the definition is very important. As I said, it depends on the time because if I talk about reliability of any system, I have to talk about up to what period of time I'm talking about because nothing is reliable for the infinite period of time, right? So I have to tell up to what period of time I'm talking about its reliability. And the second one is it also depends on the operating conditions. And because one product may be high reliability under one condition and maybe less reliable under other operating conditions. And because it is a probability, so if I talk with respect to the quantification of the reliability, its value ranges from 0 to 1 because probability the value ranges from 0 to 1. So then I will be introducing about battery nets and modeling of the system. So battery net is basically used for the stochastic modeling. And the concept was introduced by C.A. Petri. He was a German PhD scholar, and he introduced this concept to model the stochastic behavior of the systems. So we'll see what actually the Petri nets are, and what are the modeling construct, and what is the working mechanism, and what are the various properties of Petri nets, and what are the various analysis techniques. So then I will introduce the reliability prediction framework in which I'll be discussing the various phases in the reliability prediction, what all the activities that are required to be executed in various phases in that particular framework. So for that, I'll be taking a case study also, a real case study, and so that it can be useful for the practitioners as well. And then I can conclude my session. So now if you look into the mathematical definition of the reliability, so suppose x be any random variable and that represents the time to failure of a component. So it means the component is going to take this much of time to fail. So my component should not fail before this time to failure random variable because if my component will fail before this time, it will be treated as failure. And hence, the reliability of the component at time t can be given by Rxt is equal to this is the probability and this random variable must be greater than the target time because I should ensure it should not fail before the time. So from the total probability, I can write it down is equal to 1 minus probability x is less than or equal to t. It means my component has failed or my system has failed before the target time. And this is nothing but it is a failure probability. So I can write it down 1 minus fxt, which is also a function of time. Okay. And fxt can also be termed as unreliability also. So from the total probability law, reliability plus unreliability will always be equal to 1. So okay, I'm not discussing this basic thing. Yeah. So now coming about like how we can do the reliability modeling. So as I said, it depends on the reliability also depends on the operating conditions, which keeps on changing, depends on the dynamic behavior of the system. And there must be some modeling construct which should be able to model the dynamic behavior of the system. And for the one of the modeling construct, such modeling construct is known as Markov models. And the Markov models, basically, the concept was introduced by Andrew Markov, who was the Russian, who was a Russian mathematician in 1940s, and he introduced this concept to capture the stochastic behavior of the process. So if you look into the modeling construct, basically it has the two modeling construct. One is the states, and second one is the transitions between the states. So if I talk about the state, I mean the concept is like anything, any system I can decompose into the various states. For example, if human is a state, if human is a system, the various states could be eating, talking, laughing, walking, and I can transit from one state to another state. So, with this concept, the Markov chain got introduced. So, now let us see some of the mathematical concept of the Markov chain, which we will be using in our prediction framework. So suppose I and j, it belongs to the state space of the system, and let qij be the transition rate. Transition rate means number of transitions from one state to another state per unit time. So if IQij denotes the transition rate from state I to state j, then the QII, that is the transition rate from one state to that state only, will be equal to minus sum of transition rate from that state to rest of the states. Okay, so this formula is very important, which we are going to use in our future framework. And then we can define a term known as generator matrix, and which is a matrix, so it contains rows and columns, and each column represents the transition rates from one state to another state. For example, suppose there are the two states, so I can draw a matrix like this. So this is state 1, this is state 0. Similarly, I can write here, and I can fill in the element so x1 is the transition rate from state 0 to state 0. X2 is the transition rate from state 0 to state 1, like this. So this is the generator matrix. And now the Petri nets. This concept was introduced by C.A. Petri, and it is also used to model the stochastic behavior of the system. And it's a very good graphical and mathematical tool. Why it is a good graphical tool? Because I'm able to model my system using PetriNet, and I can run the PetriNet where I can see the dynamic behavior of my system as if it has been deployed in a real scenario. And it is a mathematical tool because I can embed the mathematical knowledge to derive more insights about the system, where I can solve the various state equations and algebraic equations that can give more and more insights about the system. So it's the best communication between theoreticians and practitioners. And it also addresses some of the limitations of Markov chain, because in the Markov chain, it was not at all possible for the parallel distribution, or to model the distributed systems or the parallel systems, where with the help of the patronage it is possible. So let us see the quick history about the Patrinet. So the concept was introduced in 1962 by C.A. Patry in his dissertation, who was a German PhD scholar. And the people, after going through the thesis, the people thought of like this modeling construct will be able to model the parallelism of the process, because there was an era where the people were trying to model the concurrent systems or work on the concurrent systems. And with this objective, MIT USA conducted a conference on concurrent systems and parallel computation. And the conclusions were very fruitful, and they were then try to strengthen the modeling capabilities. And with this objective, again, they decided to meet after 5 years. So MIT USA again conducted a conference on Patrinet and related methods in 1975. And then it gained a popularity, and it started being used in the industries, and looking at a good amount of uses. A course on general net theory of processes and systems was started by, like, in Germany in 1979. And then the people from different domain also were trying to explore whether this Patrinet is able to model the applications of their particular domain. And with this objective, the first European workshop on applications and theory of patronage were conducted in 1980 in France. And then the various flavors of the patronage started coming up. For example, if I want to work on the real-time system, definitely my model should be capable to capture the timing information, for which the time patronage is there, which can embed the timing information. And the first international workshop on time patronage was conducted in Italy in 1985. Similarly, there are other kind of patronage also. So although this is not an exhaustive list of the origination of the patronets, but it contains the important milestones from which this patronet started gaining popularity. And if you look into the applications, it can be used to model any kind of applications, irrespective of agricultural domain, or any nuclear domain, or any scientific domain, engineering domain. So let us see the working principle of this patronet. So suppose I want to model this small chemical reaction, which you all might have studied in class 9th or 10th. And so I want to model this equation using patronet. So first, let me discuss about the modeling construct, basic building blocks of patronet. So the figure that you are able to see is basically the patronet figure. And as the building blocks, there are the three big circles. So one is this big circle, second is this, and third one is this. And these big circles are known as places. And then there is a rectangular box which is defined as the transition. So it can have more than one transitions also, but in this case there is only one transition. I will discuss what is the roles, what is the role of each of the modeling construct. And then the places can be connected with the transitions with the help of the directed arc. So here, these are the directed arcs. And every directed arc contains the weight. For example, this is containing the weight 2. But this is not containing any weight, so by default it can be treated as 1, or you can explicitly write as 1. Okay. So we will see what is the significance of the weight. And then, so the third one is the directed arcs, you can see. And the fourth one is, you can see the embedded circles inside the places. And these embedded circles are known as tokens. Okay. And so now let us see this Patrinet figure. It basically represents the left side of this model, that is 2H2 plus O2. So because hydrogen is a diatomic, so I have put, so I'm using these three places to represent hydrogen, oxygen, and water. And because hydrogen is diatomic, and I am representing the diatomicity by putting two tokens inside these places. Similarly, oxygen is also diatomic, so I have put two tokens inside the oxygen place. Now, this distribution of the tokens basically represent the state of the system. And now here the state is only the left side, and it has to convert into the water. And if I want to convert into the water, I need to change the distribution of the tokens. And the token distribution can change by, it has some rule by known as a firing rule. So what it says is at least one transition in the Patrinet must be in enabled condition. So because here there is only one transition, it must be in enabled condition. And what is the enabling criteria of the transition is that at least the enabling criteria is all the input places must contain sufficient number of tokens. And the sufficiency of the token will be decided by these weight of the respective arcs. So because this weight of the arc here is 2, so hydrogen place must contain at least 2 number of tokens. And here it is containing 1, the weight is 1, so oxygen must contain 1 number of tokens. And in this figure, you can see like, okay, it means the transition is enabled condition. And when it is in enabled condition, it basically fires. And when it fires, the movement of the tokens occurs from input places to the output places. But how many number of tokens are moved out from the input token and how many are deposited in the output token, that will be totally governed by the weight of the respective arc. So here, the 2 tokens will be removed from these hydrogen, and 1 token will be removed from this oxygen because here the weight is 1 and here the weight is 2. And how many will be deposited? Only 2 token will be deposited in the output because here the weight of the output arc is 2. So one interesting fact is that there is no law of conservation of tokens. The movement of the tokens, it depends on the weight of the respective arcs. So now the next state will be 2 token has been removed out from here, 1 has been removed out from oxygen place, and 2 has been deposited here. And now it has converted into the water. And then you can again check with respect to the reachability, with respect to the firing, whether the transition is enabled or no. So now the transition is not enabled because of hydrogen place does not contain sufficient number of tokens, although oxygen contain. But there is an AND logic, not OR logic. And hence it is now the final state. And this concludes one interesting fact is that it also helps in identification of the entire state space of the system. So the first state was because the distribution of the token was representing the state. So it was 2, 2, 0 because here it was containing the 2 token hydrogen and oxygen was containing 2 token and water was containing 1 token. And after that, now the state has been changed like this, and now the distribution of the token will become 0, 1, 2 after firing of transition T. And this is nothing but it is known as, this graph is known as reachability graph. Reachability graph. And it can be easily converted into the Markov chain because this shows the state, and in the Markov chain, the state is represented by circle, and this represent the transition T, and this represent the another state. So it could be like state 1, it could be state 2, for example. Let us name it. So it can be easily converted into the Markov chain. So PatriNet can internally be converted. Okay, so yeah. So now let us try to understand about our reliability prediction framework. So first we need to understand the system specification, and based on which we have to create the PatriNet model. Then we have to convert it into the Markov chain. That also we have seen how we can convert, and then we can compute the reliability. We will see how we can use the mathematical concept to compute the reliability. So first, let us try to understand the some of the basic preliminaries, mathematical preliminaries, which are going to be used. So suppose pi IT is a probability that a component is in a state I at time t, where I can be the failure states or it can be the behavioral state. Behavioral state means normal states. Failure state means, for example, meeting an accident or something abnormal condition comes. So whenever t goes to infinity, all these probabilities converge to the stationary distribution. Now this is a very important fact. Suppose you do have a, let us try to understand with the help of an example. Suppose you do have a glass of water and you fill this water, then you put it down, you will see like it will settle down very fast. But at the same time, suppose there's a huge container and you fill this water, then it will take a significantly large amount of time to settle down as compared to this, right? So theoretically, if I say as time t tends to infinity for a very, very large, hypothetical large system, it may take very infinitely or infinite time to settle down. So ideally, I have written if t goes to infinity, all these probability converge to the stationary distribution, and which can be computed by these two equations. And these two equations are very simple. First is our total probability law, because sum of all the state probabilities at one time of any particular system will always be equal to 1. And the second equation is very simple. Let us try to understand with the help of one example. Suppose you fill a huge, a very big container with the water, and initially your water will be like this. Suppose this is the state S0. Now after time t, suppose your water is becoming like this. It is going to settle in. It is going to settle down. These are not labels, but I'm just showing the state of the water. Okay. So S1 will depend on, it will be equal to S0 and into the transition probability from, S0 to S1. Similarly, after further time t, if you will reach to S2, it will depend on S1 and into transition probability between 1 to 2. And at the final, suppose it has been settled down at state Sn. So what will be the state Sn plus 1? It will be the same, but the equation remains same. Sn plus 1 is equal to Sn p n n plus 1. And what is this? This is going to remain same as it was, because it was already reached to the stationary distribution. And hence, this is the same. This is a stationary distribution will be equal to same. And this is a transition probability matrix, because I'm dealing with various states. I'm not only dealing with one state or two state. So it's the transition probability matrix. And so now let us take a case study. Suppose there is an IoT system and there is a communication module, and you want to estimate the reliability of that communication module. There could be some like agriculture system where I want to send some data through the communication module. So suppose there is some embedded unit, and the embedded unit is sending the data from the field, and so this is an embedded unit, and it is getting the data from the field sensors, for example, and it is sending the data to the display unit. So the protocol is very simple. For example, you want to call your friend and you dial a number, you say hello. And if you don't get any response, you will again say hello. But after some time, you will disconnect the call if you don't get the acknowledgement, thinking that you have there is some misconnection, and you need to dial again. You need to cut the call and you need to dial again. So the same protocol has been followed over here. So when the embedded unit sends a new packet, the value of a count variable is set to 1. Suppose I am keeping a variable which is keeping a count of how many packets has been sent. And now it is waiting for the acknowledgement. So if it receives the acknowledgement before time t, I will declare the packet is successful. And if the count is less than n, because I need to define how many times I should retry, and so suppose n time I should retry, and if the count is n, and if I'm not able to get the acknowledgement, I will keep on sending and I will keep on incrementing the count. And if it is becoming is equal to n, I will terminate it and I will retry. And now this process needs to be modeled using the PatriNet. So basically, this is the PatriNet model where you can see the PSRDY0 is basically here the definitions are written here. So it means the embedded unit is ready to send the packet. And PTS0, it means the embedded unit has sent a packet and with the sequence number 1. And after sending the packet, it is waiting for the acknowledgement, which is represented by PSW0. If the token will be here, then it will be representing that it is waiting for the acknowledgement. And if the count is less than n, and if the acknowledgement has not come, received has not been received, then it can retry. This has to be resent. And it may be possible like after your data has been sent successfully. So once your data has been sent successfully, your token will be going from this transition and it can deposit here PR1R, which basically shows that your acknowledgement number has been received, a particular acknowledgement has been received. And because it was waiting here, so your token will be removed out, and the token in this basically place represent that your embedded system is already ready to send the packet. So, and now again your system will be reset and this process keeps on continuing. Okay, but if your acknowledgement is not sent successfully, so this transition will fire and it is written that acknowledgement unsuccess, and the token will be deposited in this PDSAU, and it will report that the acknowledgement has not been sent successfully. Okay, and now the question is, okay, I have modeled my specification. I need to now, quantify the reliability of this, entire model. So what I need to do first, I need to put the transition delay, and these delay basically, it can be calculated from the various machine learning algorithms, and the Bayesian estimation or the Bayesian estimate one of the algorithm of the machine learning was used, and using the specification also, these are the transition delays which are captured. It is all the transitions are in milliseconds, and those transition delays has to be put in every transition, and then you can run any tool. There are the various tools which can run the PatriNet model to find out the throughput of each transition. Throughput means the transition rates of each transitions. And after running, these are the throughput values of all these transitions. Okay. And now it needs to be converted into the reachability graph. So this is a distribution of if state 0, then after firing uh, the transition, the next distribution will be like this token distribution for each of the places. And in this way I can make the list, and then I can make the reachability graph like I have shown with the help of the two states that I had taken the example of water chemical reaction. And now it needs to be converted into the Markov chain. So this is an equivalent Markov chain, and you can see like this M3 and M8. These are the states basically which is leading from the unsuccessful acknowledgement received. And because acknowledgement was not received unsuccessfully, so what I can do to compute the reliability, I can find out the state probabilities of every state, and I can add only excluding these M3 and M8, I can add all the state probabilities to give the quantification of the reliability. So this is the transition state matrix that I have already discussed. So this from M0 to M1, so you can see from M0 to M1, it is lambda 1, and rest of all are zeros. From the equation 1 that we have put, we can see, and the diagonal values we can put, we can calculate from the equation 1 only. And in this way I can calculate the entire transition rate matrix. And now I can compute a transition probability matrix. So if I want to compute the transition probability from state to state I to state j, it can be defined as the transition rate from state I to state j divided by all the transition rates from state I to rest of the states. If j is not equal to I, and otherwise it will be equal to 0. So calculating this, I can get these transition rate transition probability matrix. And now I can use the stationary state equations. And so this was the equation that I was using. That let me go back to the same slide where we were discussing the two important equations, these two important equations. So one is like M0 plus M1 plus M2 up to M9 is equal to 1. And the second is a state equation is nothing but that was that equation. Let me come to that particular slide. Yes. Okay, so this is the stationary states which will be the same and into the transition probability matrix. And you can solve those two equations by using Monte Carlo or analytical methods, and solving that we can find out the state probabilities of each and every state in the system. And then you can exclude either the failure states and sum up all the success states to find out the reliability, or otherwise if the number of success states are many, which generally happens as compared to the failure states, so you can only sum up the failure states and you can subtract by 1. That will again give you the reliability. So because M3 and M8 was the two unsuccessful states, I have added these probabilities and I have subtracted by 1. And this will give you the reliability, the quantification of the reliability. So I conclude with this. The idea was first we need to have the system specification. I need to convert it into the stochastic modeling using the battery net. I have to assign the parameters, and the idea was I have to convert it into the Markov chain where I have to find out what are the success states and what are the failure states, and if somehow I'll be able to find the probability of being in success states, and summing those probabilities will give you the quantification of the reliability. So this was the reliability of the communication module. In this way, the reliability of rest of the components can be taken depending on the criticality, because modeling also requires a lot of effort. So depending on your criticality of your application, you can decide like which is necessary to be quantified for the reliability. So that's all. In case of any questions, I will be happy to answer.
Yeah, good evening, sir.
Yeah.
Sir, how this model can be implemented in agriculture sector?
Mhm. So because in agriculture sector there are a lot of IoT systems also,
Yes,
and
sir.
there are computer based systems also, and you can model those systems, and if you find you really feel those systems are very important to be analyzed for quantification of the reliability, and so depending on the criticality, you only have to model those systems basically, and you can model using the battery net, and where you have to understand the specification of that particular system, and you also have to have the statistical data, or some kind of design data where you can find out that can help you to find out the parameters, and those parameters can be assigned, and that can give the quantification of the system. So ultimately the crux is you need to decide whether this system is important or not. So if this system is very much important for you, definitely you will be wanting to derive the reliability of that particular system. Yeah, so one more question I am able to see, is reliability and validity are same? See, there is validity is not the right term, it is a validation. So validation means in the validation you see, other than reliability, you also see a lot of other factors. You will see the performability also. You will see uh, uh, the consistency of your system, the integrity of your system. You will also see the security aspect of your system. You will also see the function requirements of the system. So validity is reliability is a subset of the validation. Definitely, it comes under the validation techniques, but validation covers a lot of other areas also. Okay, and there could be you have to validate the function requirements as well as the non-function requirements.
Any other question? No. Thank you, sir, for your valuable information.
Yeah.
And I'm sharing the.
Before this, please take a photograph. Please ask the participant to switch on their videos. All the participants, please switch on your videos and have a group photograph.
Okay, ma'am. I'm taking the photograph.
Yes.
Thank you, sir.
Thank you.
Yeah. So like lastly, because the reliability basically depends on the data. Data is very important, and now you must be seeing like machine learning and data science. These are the very important topics that needs to be discussed, or that you need to know about it. So you can go through the fundamentals of machine learnings, which can basically use the inherent models basically for that. So probably I can share one good video lectures that I have already formulated. Probably if anybody wants, you can go through that. Okay, and that can help you. Where I have given the real case studies also, like how you can quantify the reliability, or how you can derive the data if you are having the lack of data using the machine learning, some practical applications also. So if you want, you can look into the video, and you can, if you like, you can subscribe also that. Okay.
Okay, sir. So this is a small virtual token from our side, and
Thank you.
certificate of honor. And thank you, sir, for your excellent presentation, valuable presentation for us.
Thank you, sir.
So
Thank you. Thank you.
Thank you very much.
thank you, sir. Thank you.
So request to all the participants, tomorrow we'll form a team of 6 members to study and study the research article which we submitted at the time of the submission in AICT. So please be available on time. All the participants are requested to available on the time, and so that we can make a group of 5 or 6 people in a team. That this will help you to make the reflection journal. We have to prepare a reflection journal, and the details has come from the team as a group. And also one more information is there. On Monday, we'll have the industrial visit as schedule is shared by Shivari sir in the WhatsApp group. So Monday, we'll have the industrial visit, and all are requested to come for the industrial visit. That will be there in Surabhi Satcom Private Limited in sector 11, Noida, near to our college, near to JSS ATN Noida. So all are requested to come and go for the industrial visit along with us. We all as a group of 50 people will go to for the industrial visit. Thank you very much.
Okay, ma'am.
Good
Thank
night.
you. Good night, ma'am.
Good night. Bye.